Just evaluate the limit. Limit x tends to 0, root over 1 plus x minus root over 1 minus x by x. So we want to determine the limit. Limit x tends to 0, root over 1 plus x minus root over 1 minus x by x. Observe that when we take x nearer and nearer to 0, then root 1, you will get this quantity almost equal to root 1, and this quantity also you will get almost equal to root 1, and 1 minus 1 is 0, and so it is of the type 0 by 0 form. We want to somehow simplify it. First of all, when we say limit x tends to 0, we are not saying that x is exactly equal to 0. So let's somehow be able to cancel the numerator and denominator when x is not equal to 0. In order to do that, we multiply numerator and denominator by root over 1 plus x plus root over 1 minus x. That means we are multiplying by the, let's say, conjugate of this quantity. Well, we get an expression of the type a minus b whole thing into a plus b, and that's equal to a square minus b square. So that's equal to root over 1 plus x whole thing square minus root over 1 minus x whole thing square. Denominator we copy as it is, root over 1 plus x plus root over 1 minus x. Now square and square root will get cancelled. So you have 1 plus x minus 1 plus x. Limit x tends to 0 as it is. Denominator as it is. We can cancel 1 and minus 1. Now when we say limit x tends to 0, we do not mean that x is exactly equal to 0. And when we have non-zero quantity by non-zero quantity, we can cancel that out. So 2x by x, we can cancel x out and we are left out with 2. So this is limit x tends to 0, 2 divided by root over 1 plus x plus root over 1 minus x. Now as x tends to 0, numerator remains 2, denominator you have root 2, as x tends to 0, denominator we have root 1 plus root 1. So that is 2 by 2, which is equal to 1. So the limit x tends to 0, root over 1 plus x minus root over 1 minus x by x is equal to 1. Let's look at the part B. Limit x tends to infinity, root over x plus 10 minus root x. Observe that as x tends to infinity, that means you take bigger and bigger value of x, x plus 10 will get bigger and bigger, and so does the square root of x plus 10. And so does square root of x as well. But we want to compute this limit. Does that limit exist? This quantity is also getting bigger and this quantity is also getting bigger. But what about the difference? Again, in this case also, we will multiply by root over x plus 10 plus root x and then divide by root over x plus 10 plus root x. Now, once again we have a minus b whole thing into a plus b. So you have a square minus b square. Now square and root will get cancelled. Square and root will get cancelled. We are left out with x plus 10 and x here. The difference is just 10. So we want to determine limit x tends to infinity, root over x plus 10 minus root x. Observe that as we have observed earlier as well, root over x plus 10 gets quite big as x gets bigger, and so does root x. So you expect bigger minus bigger, something to be a quite big number. But what we observe is that as x tends to infinity, 10 by root over x plus 10 plus root x, you observe that denominator gets bigger and bigger. So 10 by denominator will get smaller and smaller, and you will have it exactly equal to 0. So the limit of this difference is exactly equal to 0.